Hello, in this presentation I am going to talk about LINQ. LINQ is where the money is. That's why you want to pay attention. If you go on Indeed.com and you search for C# jobs, you will see that most of them have LINQ listed in the description or in the list of technologies that they want their developers to have. It just seems to make sense that if you were going to learn C# that you should make the effort to get LINQ under your belt. If you already have experience with databases, I think you will find LINQ to be very, very powerful and useful after you spend about 15 minutes hating it and getting used to the syntax. However, once you have gotten through that period, I think you will find LINQ to be very, very useful. So let's take a look at LINQ. LINQ stands for Language Integrated Query, and it's a set of features that allow you to perform SQL-like operations on a variety of data sources. And that's the real power of LINQ, rather than having a technology for just working with XML data, or a technology just for working with databases, or a technology just for working with objects in memory. Now we have just one set of language features that we can use to perform operations on all of these different types of data. It really is kind of like the one ring to rule them all. In fact, they probably should have called it ring or RINQ. I don't know. It's very powerful. Moving on. So LINQ supports the exact sorts of operations that we just saw in the SQL demos, and those are the CRUD operations, create, retrieve, update, delete. So the types of things that we're doing with LINQ are exactly the same sorts of things we were doing with SQL. It's just that the learning barrier, or the hoop we have to jump through, is that the operations are specified in a different order, and the syntax is a little bit different. But if you understand what you were trying to do in SQL, LINQ is pretty easy to figure out, because if you understand, oh, I just need to join these two sets of objects, these two collections, great. Then you can just Google LINQ join, and you'll find the syntax. If you know what you're trying to do, just looking up the syntax is very easy. So what we saw in the last videos, the last presentations where I did the SQL demos, were queries like this. They would start with a select, and we would say what columns we wanted to pull out of the database, or pull out of the table, and then we would say what table those columns applied to. So I'd select like the first name and last name from author. And then we would supply a where clause where we would filter the results based on some criteria that was important to us or mattered to us. And then maybe we would sort those ascending or descending, maybe by date or by age or by cost. And if we had a lot of data coming back, maybe we would want to limit the number of records in the result set. So we would have something in the form on the left. And I haven't put in joins because they're kind of big and they take up a lot of space. But we'll talk about how to join two collections later in the slide deck. And let's look at what LINQ does by contrast. So it has actually has the same stuff. We have a from clause, a where clause, an order by, select, and take. We have take instead of limit. Pretty much exactly what you saw on the left, but the operations are going to be performed in a different order. So in LINQ, your from clause comes first, followed by where, and then going down all the way to select. So select is usually at the bottom, and then if you want to filter the results, then you put a take expression around the entire query. So the LINQ query is going to look a whole lot like the SQL query, but the steps are going to be specified in a different order. So let's take a look at what kind of things can we perform LINQ queries on. You can perform a LINQ query on anything that implements the IEnumerable interface. So remember, an interface is a contract. It's a list of functions that you agree to implement. So an object that implements the IEnumerable interface just allows you to loop through it and look at the things in it. There are lots and lots of collections that implement the IEnumerable interface, ArrayList included, but never, ever, ever use ArrayList. It's a legacy collection type, and you should not use it because of the penalty associated with boxing and unboxing. And you should know what boxing and unboxing are, because that's a standard interview question. Oh, I love recording right by the train tracks. It's awesome. Okay, pause. All right, I'm back. That must have been the 856 going to Chicago. Okay, so we can perform these queries on anything that implements IEnumerable, right? And IEnumerable is just a set of functions that a particular collection implements that allows you to loop through. The elements, right? And this is the form for a query. So this is very similar to what we saw on the previous slide. It's just a little bit more detailed. Our from clause or from statement is going to come first. We have to say what collection we're selecting our data out of. And then if there's a join, we're going to specify that next. And then finally, we'll go on to filter any records that we want based on some condition. And if we want to order them, we can do that. We can do it ascending or descending. Ascending and descending are LINQ keywords. And then finally, at the end, we can select out the specific fields that we want. So in a SQL query, the select comes first. In a LINQ query, it comes last. So a LINQ query is really, it follows the structure of a SQL query, but kind of upside down. And I will admit, I found this frustrating and kind of hard to get used to, but through repetition, it'll come, and then it won't be such a problem anymore. It's just kind of like a for loop. It's like, it's a little bit to learn the syntax, but once you know the syntax, it's okay. Then you're past that barrier, and now you can do productive things with that syntax or that feature set. So let's look at a very, very simple query here. I have an integer array called numbers declared at the top left. So imagine I've got that in my code somewhere in my class, and I want to perform a query on it. Here's a very simple query. From num in numbers, select num. Hopefully that is kind of decipherable. However, let's take a kind of a look at it. Think of the from statement as a for each loop. And when you have a for each loop, you have to have a loop variable that kind of keeps track of the element in the collection that you're currently looking at. And if you understand that a from clause is really just a for each loop, then this loop variable kind of makes sense. So when you have a from statement, you have to put in a loop, an alias or a kind of a loop variable to refer to the element that you're currently, that the query is currently looking at as it loops through the data in the collection. So it doesn't have to be called num, it could be called whatever we want. We just call it n. From n in numbers, select n. So what that's going to do is it's just going to loop through numbers and put everything in the result set and return us the result set. If you're wondering, like, where do we get the result set? That comes, I'm going to show you that in a slide or two. Right now, I just want to focus on the syntax of the query, right? So we have our from statement, our loop variable, and our collection. And then finally, we're going to select out of that process. We're going to select out the ones that we want. We're going to select the right now we're just selecting the number, but as things get more complicated, we can select out specific fields from objects. But the purpose of this one is just from. If you understand, from comes first, followed by select. Now, what comes back from our query? We get some object that implements an IEnumerable interface, or implements the IEnumerable interface. We don't really know what object that is. We don't know much about it, but we do know that it implements the IEnumerable interface. And so if we kind of could figure out what our return set was going to be. So in that previous example, where we're selecting out integers, we're going to get an IEnumerable of type integer. And we could kind of figure that out on our own. But if we're doing a very complicated query with joins, it's like, then it gets kind of messy. That is why C# has the word var built into it. Var has a very specific meaning. Var means let the compiler figure out what the type of this variable actually is. Now you shouldn't use var. I would never use var except within the context of a LINQ query. It just bugs me. I don't do it. I think programmers should specifically say what type of data that data type their variables are. Don't use var except in the context of LINQ queries, because in LINQ queries you really do need var. But var means let the compiler figure out the type based on the context. And so var does not, it's not like JavaScript where you could say var x, and 1 minute var could contain an integer, and the next minute it could contain a string. It doesn't mean that the type can change. It doesn't mean it's a variant, which is kind of a older technology where variables could have multiple values of different types. It doesn't mean that. It has a very specific meaning. Var means let the compiler infer the type from the context, and I'll show you that. in a second. Actually, I'll show you that right now. Let me pop over to Visual Studio here, and you can see I have made a statement here, var x equals 5. Now, I would never ever do this writing code. I would say int x equals 5. But if I hover over this, you will see that the compiler has figured out that x is an integer. So what the compiler has done is it has inferred from the value on the right that the type of x must be integer. So var doesn't mean it could be this, it could be that. Var means let the compiler figure out what the type of x is based on the context in which it's being used. Actually, if I hover over results, you'll see that it's an an I-ordered enumerable of type integer. So var doesn't mean who knows what it is. Var means let the compiler figure out what it is based on what is being assigned to it. So the compiler can figure out, okay, right, this thing is going to return an I-ordered enumerable of type integer, right? So that's what results actually is. It's now those things as I enumerable of whatever, and imagine this is a very complicated query. Those types get very complicated very quickly. So we just refer to the results as var. That's what var means. Var means let the compiler figure out the type. Moving on. Okay, so here was the result of our query here. Our query returns an IEnumerable of type integer, basically a list. An I-ordered enumerable actually is an IEnumerable. So we can see here that this LINQ query returned us kind of something that implements a list-like set of features. Now that's horrible to have to write. And God help us if we had to write I-ordered enumerable of type int and type that without making mistakes. So we can just substitute in var. Var results equals from num in numbers, select numbers. So this is going to select all the elements out of our numbers list up here. And we're going to end up with a result set. And what's the type of result set? Well, it's something that implements that IEnumerable interface, which means we can loop through it and look at what we got. So that's what var is. Var is for kind of referencing the result set that you get from a LINQ query. I would not use var at any other context. Just drive me crazy. Okay, let's look at a slightly more complicated LINQ query from num in numbers, where num mod 2 is equal to 0. Select num. So what this is doing is it is selecting. It's really looping through numbers, and if that particular number on any loop iteration happens to be evenly divisible by 2, that's what the %2 means mod 2, divided by 2, take the remainder. If it's 0, select it, put it in the result set. So what this is going to do is it's going to give us back all of the even numbers and put it into some object called results that implements the IEnumerable interface, which means we can loop through our result set and see what we got. So notice again, the from clause comes first, and the select clause is at the bottom. So it's kind of like a SQL query flipped on its head. Order by. So now let's say that we had a query and we wanted to order the results. So just order by, one word here, is not a typo. That's the keyword in C#. And this capital O here should be a lowercase o. I hate the case fixing. It's like autocorrect failure, driving me crazy. So order by, one word, and that allows you to sort the result set before you get it back. And you can specify the order of the sort using ascending or descending, right? And sorting by ascending and descending. Well, now we're getting into those iComparer and iComparable interfaces that we looked at in the previous exercises. So we can order our results. We can sort our results using an order by clause. So let's take a look at that. Let's throw an order by clause into, or an order by statement into our query. So from num in numbers, where the number is even, now order them in descending order, and then finally return the results. Now, the select is that's kind of where you get your results back. So there we've got from, where, order by, select. So again, looks very similar to an SQL query, but just kind of flipped on its head. And I guess also you may have, if you're good with SQL, you may have noticed that we use the double equal sign here for comparison, just like we would in any other context in C sharp. But I know in SQL you'd probably just have one equal sign there. In the LINQ query, it just follows the standard rules for comparison. You just use the double equals. So there's a slightly more complicated query. Just select all the even numbers, sort them in descending order, and give them back to me. What if we had a lot of data coming back, a lot of records, and we just didn't really care to see them all? What if we just need the first 10, first 5, first 100? How do we do that? In SQL, that's limit. In LINQ, that is take. So what we're going to do is have a LINQ query, and then around that we're going to put parentheses to kind of group that whole thing into one unit, and then we'll say dot take, and then however many records we want. So here's what that take operation looks like. We have our query, and then we put parentheses around the entire query to kind of say we're applying the take operation to the results to the results of the previous thing, and now we're just going to select out 5 of them, the first 5. So if you want to use a take expression, you need to apply it to the collectively to the entire query, and that requires you to put parentheses around the query. So just remember, if you want to use a take, you need the parentheses. All right. Now, in these previous examples, we've just been selecting integers out of a list, and that's not a very real world scenario. I don't see that job on Indeed. What a much more realistic scenario is that we have some collection of objects, and those objects have public properties or public variables, and we want to select out those fields, right? So when we were doing our database queries, we're selecting the title or the price or the name and the price or the name and the publisher or the publisher and the date or something. We're selecting out a set of particular fields and getting that back. So what does that look like in LINQ? Well, this gets kind of interesting, because if we're doing an operation on a collection, we're trying to retrieve records, and we're just trying to pull out particular fields, like we've got a student record and we want to pull out first name and last name and GPA, and not address, social security number, what their cell phone number. We just want to pull out a few fields. What we have to do is really make a new object to store just those 3 fields. Like we have to kind of create a new type on the fly. And LINQ will do that for us. It can look at the query and say, okay, you're returning these columns or these fields out of your as part of your results. So I will make a new object that stores those fields. However, we don't see the name of that object. It's an anonymous object. And because it's anonymous, we can't make a variable of that type to refer to it. So that's where var comes in. That's why we need var, because we're getting these kind of an anonymous type back. And in order to refer to it somehow, we need to use var, because var means let the compiler figure out the type, because we don't know what it is. And we'll look at that on the following slide. So imagine that we've got a student object, and a student has a lot of data fields in a particular record. So we've got a first name, last name, social security number, GPA, cell phone, parents' first name, parents' last name, all that stuff. There's a huge amount of information stored in every student record. And imagine we just want to find a list of students who are, have a GPA of 90 or better. So we want to pull out first name, last name, and GPA. When we do that, we're creating new objects that just have first name, last name, and GPA. And we didn't make those objects. The compiler made those for us, right? So that's why we need var to refer to those objects, because we didn't make that object, so it doesn't have a name. So let's take a look at this. Now let's imagine that we have a list of students. Here's our from clause, from S in students. That's our kind of little for each loop that's going to crawl through the records. And then we can say where that student's GPA is greater than or equal to 90, select, and then we say new, and then we can provide the fields that we want in our result set. So this object will actually have, what this query will do is on the fly make an anonymous new object that has an F name, L name, and GPA fields. That is why we need var. We don't know what the name of that object is that's being returned by this query. So we're going to get an IEnumerable of that object whose name we don't know. And that is why we need var. So when you are selecting particular fields or properties out of an object, you need to use the new keyword and the parentheses and then provide a comma separated list of the fields that you're interested in. And this is what you're going to do most of the time. Most of the time you don't, you're not going to do a select star. You're going to pull out specific data. So when you are just doing that, you need the word new followed by the fields that you want specified in the curly braces. And you can do some pretty cool stuff with when you make new objects here. So let's say we want to just get the names of these students, and we want to create a new field that's a combination of the first name and last name. So in this example here, we are selecting all the students whose GPA is greater than 90, but we're creating a new field in this object called name. And name is actually, we're going to take the student's last name, stick a comma on it, and then stick the first name on. So we're making a new field here in our results set called name that is a combination of the existing fields. This is kind of like a calculated field. So notice there that we are creating a new property based on some existing properties. And we have the new keyword, the curly braces, and the semicolon on the end. So this is an example of selecting but creating a kind of a new column that's the result of or a combination or an operation on existing columns in that object. All right, so let's talk about let me go back to this here. So one of the reasons that you would rename or provide a name to a column is if you have a name collision. Let's say we're joining on two tables and each table has this field with the same name. Or the object that's coming back can't have two fields named social security number because they're coming from two different tables. So you can provide a new name for one of those fields coming back in the result set. There's an example of this later on, and it will make sense in that context. I promise, I swear. So joins, very, very common database operation. The whole point of a relational database is to optimize storage and retrieval by breaking stuff up into tables, right? So when you want to select information back out, now you have to kind of reconstitute the data which has been broken up into tables, and the join allows you to do that. So let's look at how joins work. When you join to a table, you have to specify what table you want to join with, and that join expression is going to have its own little loop variable. What's really going on here is when you're doing a join, you have a nested loop. You're doing a kind of a for each loop through one table and a for each loop through another table, and where the records match, you kind of take the data from one table, from the left table to the right table, and you stick them together, and that becomes your result. So a join is really a for loop or a for each loop inside of a for each loop, or it's a nested loop. So that means that our join statement is going to have a loop variable as well, just like our select statements do. And when you are making an association or testing for equality inside of a join to match up the records in two tables, like I need the publisher ID from this field to match up to the ID in the other table, you use the word equals or the equals operator instead of the double equals. That's just part of the syntax of LINQ. Equals is one of those four functions that is built into every object in the .NET framework. We've got equals, toString, get hash code, and get type. I think those are the four ones. I would know that. That's probably a good interview question. More of the four methods built into every object in .NET. So when we are doing our joins, we use the word equals or the equals operator instead of the double equal sign. So let's take a look at a join. So imagine that we've got two tables, categories and products. So here's our from, that always comes first. The from always comes first. And so we've got a loop variable called category, and we have a table or a collection called categories. So from category and categories. And now we're going to join onto the products table. We're going to associate the categories and the products. So we have the word join followed by a second loop variable, which is kind of an alias for the element we're looking at as we crawl through the second table, and then in products, of join, prod, in products. So that is making the join there. We're saying, okay, so loop through one table, or one collection, now loop through the other collection and try to match them up. So how do you match them up? Well, that's where you provide an on statement afterwards, after the join, where you specify the two fields that you're trying to associate. So in this example, the category or the ID field in the category is supposed to match up with the category ID in the product table. This is just a hypothetical example from Microsoft's own documentation. Don't worry about what these things actually mean or if they make any sense. But just from the context here, we know that the ID field in the category table is supposed to match up with the category ID field in the product table. So loop through these records, loop through those records where they have these fields in common. Now we're going to just select out some of those columns. So we're going to select out the product name and the product category. Now let's take a look at what's going on in the bottom of this query here, where we're selecting just these two fields out. We're selecting, well, what are we selecting? Notice that the product table has a name field and the category, the product collection has a name field and the category collection has a name field. That's a problem because the new object we're creating can't have two fields, two properties named name. So we have to be able to provide new names for the fields that we're selecting out of our collection. So what this is doing is it's selecting the name from the product table and renaming that property to be product name, and it is selecting the name from the category table and it is renaming that to be category. So this is an example of why you would need to rename a field in your result set object, in your result, because there's a name collision in the table. So this is kind of a contrived example, but I mean, think about how many times, every table's got an ID in it. So if you're doing stuff on collections and they've got an ID field in both collections, you'd have the same problem. So you might have like student ID and like class ID or something like that. You'd have to rename those fields to address the fact that you've got a name collision. There we go. Okay. Wow, I did all that talking and I forgot that I had slides to say what was coming up. So with our join here, there's our loop variable for the second table and then followed by the name of the second table. And then inside of our on statement here, notice that we're using the word equals instead of the double equals. Now it's okay to use double equals in a where clause, but in a join you have to use the word equals. All right, there we go. I already said all this. Ugh, the dog barked and I got all out of whack. There we go. Okay. Moving on. What if we want to have more than one join in a LINQ query? Well, no big deal. You just have a second join statement, and in that join statement, you have to have you will now have a different loop variable. So every time you have a select or a join, you're going to have one of these little loop variable aliases, and you have to say what fields you're associating. So this is all we want to do. If we have to just join to a separate table, more than one table, that's fine. Just have more than one join statement. No big deal. Just make sure that you've got different loop variables there. So we have I, S, and T, kind of our little loop variables. And then in our result set here, we're pulling out title from the table T, we're pulling out the quantity from the inventory table, and we're pulling out the city name from the stores table. I'm not sure if does this query make sense. I'm not really sure, but that's not the point. The point is, if you want to have more than one join in your LINQ query, that is fine. Just specify them all sequentially, the same way you would just have one join. Again, very very common operation is to have join two or more tables together. And again, notice that when we're selecting our new object here, we're going to get a new type back that's got these three fields in it, and we're going to refer to that using var because we don't know what this type is. The compiler will figure this out at compile time. It will make up some anonymous type for us and put the results in it and return it to us, but we don't know the name of that type. It's kind of generated behind the scenes for us, so we're going to use var to refer to it. Var will be an object that implements the IEnumerable interface of whatever this type is. All right. Here's one very interesting feature about LINQ, And that is, you don't actually get the results, or the query does not actually execute until you try to use the result set. So there may be a time delay between when you write the query and when you use the result set, and it's possible that the results might change between when you think you ran the query and when you actually did run the query. So let's take a quick look at what I mean by that. So if I pop over to Visual Studio, you see here's just like a silly little LINQ query. Now you might think that this statement will populate this collection right here, this list, that we'll get our result set immediately upon executing this statement. But it turns out that's not true. The query will not execute until you try to access the result set, and it's the act of accessing the result set or trying to iterate through the result set that triggers the execution of the query. So let me type in a for each loop here. And now you see, oh, right, that's why we have var, because we don't really necessarily know the type of our that we're getting back in our collection or in our result set. Now, and I do like console.writeLine or something, item. This query, the result set does not get populated until I execute this. It is the act of using or accessing the result set that triggers the query to execute. So you may think that your query executed here, but it doesn't. It actually executes here. It's kind of weird, I know, but and normally it's not an issue, but it's one of those good to know things. Now, how does LINQ actually work? LINQ is built using extension methods. Now, I love extension methods. They're just so cool. I use them all the time. They are that mechanism for bolting new keywords or bolting new functions onto existing objects without modifying the existing objects. So all of these LINQ keywords right here are actually extension methods. And if you hit F12, you can sometimes, there we go. So look, it'll take us into the source code. You see, oh look, static function and to this pointer. That is the key giveaway that this is an extension method. And if we scroll all the way to the top, no doubt this is all part of a static class. So those are the three things you need for an extension method: static class, static function, and that function has to have a this pointer that refers to the object that is being operated on. So that is the relationship between LINQ and extension methods. LINQ is implemented using extension methods. Those two features were released simultaneously in the same iteration of C#, right? You can't have LINQ without the extension methods. And so that's it. That's the crash course for LINQ syntax. And then what we're going to do in the next video is I will actually write some LINQ queries, talk through what I'm doing, and then hopefully it'll help, hearing it and seeing it will help it sink in. And I will be the first person to admit that, like, if you're not, SQL is kind of a bit weird if you're not used to using it. And now we've gone from SQL to LINQ, so we're taking something we're not familiar with, and now we're kind of translating it into something we're less familiar with. I really understand that, but to ease your anxiety, if you just do this a bunch of times, it becomes second nature, and you'll remember the syntax. You'll remember what you're trying to do. So it comes through repetition, just like writing a function when when you're starting out, writing a class. You're like, I don't remember it. But if you do it enough times, eventually it sinks in and it will become second nature, and it is very powerful. So in the next video, what I'm actually going to do is I'm going to go back and I'm going to do all of those queries that we did directly on the database in SQL. I'm going to mock those up and do them using LINQ so you can see how they're different. All right. Well, if you've made it this far, pat yourself on the back. That was a long one with some pretty arcane material. So, but just keep in mind, LINQ is where the money is. That's why people are hiring C# developers. No one is paying you to make the annoying button that hops across the screen or connect 4. They are paying you to do database operations. So, hope that was interesting, and I will hopefully see you in the next video.